Okay, so now we're going to get into uncertainty, okay? If you're watching these videos in order, that last one, it cut me off in mid-sentence right there at the end, but I was just about done anyway. It doesn't matter. You didn't miss anything. So going back to measuring the box like I was talking about before, say I want to measure how wide this box is, okay? So notice there on the left on the board I wrote width equals 28.0 plus or minus 0.1 centimeters. So I put an uncertainty on it, and most of you I expect have probably had some experience with uncertainty already, but basically what we're saying there is the width could be as much as 28.1 or it might be as little as 27.9. So we say 28 plus or minus 0.1. Okay, so that's what we do there. Now, why did I choose 0.1? Where did that come from? Okay, so here's a ruler similar to what you are probably using, and you look on the top scale, those smallest divisions. Okay, on videos sometimes they get kind of blurry. You might want to look at yours for real, but the smallest division is 0.1 centimeter. So that's an unreasonable amount to use as an uncertainty, which is what I wrote there on the left. So plus or minus 0.1 centimeter or plus or minus 0.05. The 0.05 comes from if you thought you could read it to half of a small division. Okay, if it was a really nice measurement where everything was real square and lined up really well, then maybe you could do that. Okay, so but most of the time we say 0.1 just to be safe, but yeah, you could use 0.05 sometimes. All right, so that's based on the smallest division. Now that might contradict what you might have learned somewhere else, possibly in a chemistry lab. They might have said, or a biology lab, they might have said that you could estimate to 1/10 of a division. Sometimes you hear that, okay? So I'm not saying they were wrong if they taught you that. It depends on the instrument, depends on the situation. So, don't go to the biology department or the chemistry department and rat me out and say Finterest said y'all don't know what you're doing. No, I don't mean that. But let's say you had a beaker of water here, okay? I put red dye in it so you can see it better, but it's just water. This would be more typical of something you might do in a chemistry lab. So you can read the level of the water pretty easily. It shakes a little bit because I'm holding it with my hand, but if it were sitting on a table, it would be settled down. And the divisions are pretty big, right? So that's a pretty straightforward measurement. So estimating 1/10 of one of those, that's doable. You can do that. All right, but going back to our ruler, which we use quite a bit in physics lab, okay? So these divisions, though, if you look at those, they're pretty small, right? So 1/10 of one of those guys, that's not happening. So hopefully you can agree with me on that, okay? So 1/10 of one of those is really not too realistic, at least not accurately anyway, okay? So that's the deal on that. Now, we'll talk about calipers a little bit. So by now, I think you will have received a vernier caliper, a plastic one in the mail, along with a few other little knickknacks, okay? Let's say, here's your caliper, okay? And by the way, if you have access to a better quality caliper than this, then, you are totally free to use it. We sent you these, but if you have a metal one or a digital one even, and you want to use it, well, go for it. But anyway, these were cheap, and it'll introduce you to it anyway. So you would measure it, say, like, let's say I had this solid metal cylinder here, and I wanted to know the diameter of it. I can put the caliper around it like that, and then read the numbers. We'll get into reading the numbers here in a second. But anyway, that's how you actually measure that. Now you're going to notice in this there's a little gap in there, a little space. Don't let that throw you off. If you were measuring something pretty small, like say a coin, you might be able to get it up in that gap, but you don't want to do that because you want to use the lower part of the jaws here, okay? So I don't know why they put that gap there, but anyway, don't let that little gap throw you off. All right. Let's let's see. So now how you actually read those numbers, you're going to notice there on the board there's a looks like a big caliper sitting there. Let me get it. All right. So this one is an old model we have. It's really pretty old. It's older than any of you all are. It's not older than I am, I'm sorry to say. But anyway, so here's this model, like this big model of a caliper. I don't know if it measures anything, but it's good for explaining. So let's say you were trying to read this measurement, and the first thing you do, this part here, the part that can actually move, that can slide back and forth, I call it the slider, okay, just to distinguish it. I don't know if that's the official name, but I've always called it the slider. So you look at the marks on the slider, and the first one, the 0 mark, you use it as an indicator, and you see where it lines up with the ones with the scale on top, and hopefully you can see that the 0 mark on the slider is between 1.6 and 1.7 on the top scale. Okay, so between 1.6 and 1.7, right? So that tells us we're good for 1.6. So we're good for 1.6. Now we can get a second decimal place, and you can get it by looking down here, and you find a place where the top mark and the bottom mark line up well. And okay, I hope you can see that the mark number 7, see the little 5 down there, then 6 and 7. The number 7 mark lines up with one above it pretty well. Not perfectly, but maybe better than any of the others. So that tells us the second decimal place is a 7. All right. So we first determined we had 1.6. Now we've got 7 in the second decimal place. So our total measurement is 1.67. Okay. Now this can be a little bit of a headache trying to find a mark that lines up. It's harder on a little caliper. Sometimes you stare at them a while and they seem to sort of blur together and you kind of forget what you're doing. So it can be a little tough sometimes. Couple things that can help you out is, let's say the first reading when we just were determining where the 0 mark is, okay, on that, okay, it's between 1.6 and 1.7, but it looks closer to 7, right? So that tells us our total measurement, we would expect it to be maybe something like 1.6 or 1.7 or 1.8 or 1.9, like on the higher end, because we're closer to 1.7 than we are 1.6. So that's a clue, all right, that by picking 7, we're in the right ballpark, all right? So you can tell that. In other words, you can sort of estimate like you do in chemistry, but I just told you not to do there, and that gives you an idea of what you ought to expect from the second decimal place. Okay, so that might help you out. Another thing that might help you out is to look at the pattern as a whole. Don't just focus on the mark that you think matches at first, but look at the whole pattern. You see here that marks do not line up very well, but they get better as you go over, okay, and then you get to the number 7 mark, and that's about the best match you get. Then it starts to deviate a little more here. So look at the pattern as a whole, and I think that'll help you out a little bit, okay. Now, the other thing that makes it a little bit more complicated on your caliper, the ones we got for you, is you've got these marks, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the bottom. But then your caliper, your small one, actually has half divisions too in between these. So you can get even another decimal place, like a third decimal place. It would just either be 5 or 0 because it's only half in between. Okay, so that makes it even more complicated. And at least in my experience so far, trying to use that little caliper, it seems like a lot of the time maybe there's 2 or 3 marks that look like they could all line up, and it's hard to pick which one. Just go for one of them. Just do the best you can with it. All right. Now, precision on a caliper. So that's what I've written up there. So this is for your caliper, the black one that you got in the mail. Technically, it should be able to measure to 0.005 centimeters because of those half marks, okay? Realistically, probably not so much. So I would say at best you could probably get plus or minus 0.01 centimeter out of it, okay? That last one, you know, just do the best you can with it, but I think you can get 0.01 centimeter out of it anyway, okay? So that's the deal on that. Alrighty.